Okay, hopefully you worked on these before you found this answer key video. Let's look at number 1. We're rationalizing the numerator, which means the radicals in the numerator need to go. So tell me what you want to do. You want to multiply. Tell me what you want to multiply the numerator by. It's conjugate. Great word. So tell me the conjugate. 3 times the square root of 5 minus 4 times the square root of 3. Great. Okay, so before I do that to the denominator, I'm going to do my work off to the side, okay? Because I want to make certain things work out the way they're supposed to. And remember, you might be able to reduce once you actually have this multiplication product done. And I don't want to distribute the denominator too quickly. Okay, so I have 3 square root of 5 times 3 square root of 5. Good, 9 times the square root of 25. And then I'm going to multiply negative 4 root 3. Negative or minus 12 square root 15. Good. And then I am going to take 4 square root of 3 times the 3 root 5. Good, positive 12 square root of 15. And multiply it to the last one. Negative 16 times the square root of 9. Excellent. Do you see what's happening? Yeah, gratefully these two guys in the middle drop. Bye-bye. So 9, okay, what's the square root of 25? 5. So we have 9 times 5 minus 16 times 3. 9 times 5? 45. 16 times 3? 48. I end up with a negative 3, don't I? So it worked for the numerator. I was able to cancel out the radicals, which means I'm going to multiply the denominator by the exact same thing. So let's see what this looks like. We have the numerator turned out to be a negative 3. Wonderful. The denominator is 15 times this wonderful looking parenthesis. There's a lot going on in that parenthesis, but that's okay. But do you notice you can reduce? Yeah, that's why I don't multiply the denominator right away, because if I'm able to cancel, I want to see what I can cancel, and I can see it very easily this way. Okay, so simplify the denominator, multiply this through 15 square root of 5 minus 20 square root of 3. Oops, don't need those parentheses, do I? Okay, good on number 1. Did you get that same answer? Excellent, I was hoping you did. Okay, so number 2, stay focused. There's radicals, square roots, in the numerator and denominator, but stay focused on the directions. The directions say to rationalize the numerator. So the numerator is square root of 7 plus 3. Stay focused. So I'm going to multiply the numerator by the square root of 7 minus 3. Okay, let's do some side work here. So square root of 7 plus 3 times its conjugate. Okay, so that'll be 7 minus 3 root 7 plus 3 root 7, right? And then minus 9. Yay, these two in the middle drop out. And I have 7 minus 9, negative 2. Okay, so it worked. It worked in the numerator. I was able to cancel the radicals. So I'm going to multiply the denominator by the same thing I multiplied the numerator by. Okay, so we have in the numerator negative 2. Uh-oh. I have a multiplication problem with a bunch of radicals going on in the denominator. So do it separately. Don't do it in the problem itself, because when you do it in the problem itself, it gets really messy. Do the side work. Okay, so we kind of know what it's going to look like because we somewhat did it over here, but the signs were opposite, so things are going to change a little bit. So square root of 7 times itself, 7. Yep, minus 3 square root of 7, minus 3 square root of 7, plus 9. Good. So we have 16 minus 6 square root of 7. Good, 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 good. Excellent. Now, are we done? Good, we're not, because I notice I can reduce, can't I? And here's the easy way to see it. There's basically a 2 in the numerator. Let's factor a 2 out from the denominator. What remains? 8 minus 3 square root of 7. Excellent. The 2's will cancel, won't they? Which leaves me a negative 1 over 8 minus 3 square root of 7. Good? Yeah, this problem number 2, the reducing wasn't obvious on this step as it was here. So I had to pay close attention to the coefficient of that square root and this term here, and gratefully I could factor a 2 out to cancel. Good? Okay, I have that third problem coming your way, so stay tuned. So here's that third problem. Hopefully you worked on it before you got to this answer video. Tell me what you did. We're rationalizing the numerator. Tell me what you did. Good, you multiplied by the numerator by something. Tell me what you multiplied it by. Ooh, that fancy word called conjugate. Tell me what the conjugate is. 3 square root of 6 minus 5 square root of 7. Good job. Okay, I'm going to come off to the side and do some side work here because I don't want to ever do my work in the same or in the problem itself. It gets really messy. Okay, so 3 square root of 6 plus 5 square root of 7 times its conjugate. Okay, so 3 square root of 6 times itself, 9 square root of 36. 3 square root of 6 times the negative 5 root 7, negative 15 square root of 42. Good. And now 5 root 7 times 3 root 6, positive 15 square root of 42, and then times it by, gives you a negative 25 square root of 49. Excellent. So it looks like these two middle terms drop. That's good. That's what we wanted, right? Okay, almost there. Square root of 36 is 6. So we have 9 times 6 minus 25 times 7. Good. 9 times 6. 54 minus, think of 7 quarters. There you go, 175. Okay, so what do you get when you subtract that? Right? Right. Okay. So the numerator is 121. Got it. The denominator. Yep. Multiply by the same conjugate that you multiplied the numerator by. Okay, I got some work to do over here on the side because that's going to look too ugly in the problem itself. So let's see what happens. We have 2 square root of 6 minus 3 square root of 7 times 3 square root of 6 minus 5 square root of 7. Okay, talk me through it. Good, 2 square root of 6 times 3 square root of 6. 6 times the square root of 36. Got it. And then you're taking this term and multiplying it not just by the first one, but by that second one also. Negative 10 square root of 42. Good job. Nicely done. And now I get to take this negative 3 root 7 times each of these. So let's deal with the first one. Good. Minus 9, square root of 42. And when you multiply by the last one, positive 15, square root of 49. Good, good, good. Take it slow, one step at a time. We don't have to rush this, right? Okay, what's the square root of 36? So we have 6 times 6. Now these two I can combine to minus 19 square root of 42. Gratefully, they both have the exact same square root. Otherwise, that would not have been nice. Plus 15 times 7. Good. Okay, let's keep simplifying. This is a 36. Nothing's changing on the middle term. And you've got 15 times 7, which is, good, 105. So far, so good? All right. Can we add the 36 and the 105? Sure. We get 141 minus 19 times the square root of 42. Well, that's a lovely denominator. Now you know why you kind of do it off to the side. It looks really ugly if you work on it in the problem itself. Okay. Question. Can I do any reducing? Let's think about it. 121. I know 11 goes into 121, right? Question is, can I factor out 11 and 11 out of these two numbers? I cannot. So in this particular case, that doesn't reduce. That's the solution. Or I should say that's its simplified format. Good? Okay. Hopefully this made sense to you. If you need to rewind and watch any of these particular examples, please do so, because problems 1 and 3 were very involved, as you can tell. So have fun. I'll catch you on the flip side.